Welcome to qnawire.
In problem 34, we have a converging lens, and there's a real object, and the lens is a focal length of 9 centimeters, and the object has a height of 4 millimeters. And we're told that the image formed by this object has a height of 1.3 centimeters or 13 millimeters, and that the image is erect, so therefore y prime is greater than 0 or positive. And we're asked to find the object distance and the image distance and whether or not the image is real or virtual. So we can use equations 34.16, which relates the object distance and the image distance to the focal length. So we're given the focal length, and S and S prime are two things that we want to find, but I have two unknowns in one equation, so it's not sufficient information, but I'm given the heights of the object and the image, so I can use equation 34.17, which relates the magnification to y and y prime, and also S and S prime. So this part is the important part, the relationship between S and S prime and y primed. So now I have two equations and two unknowns. Therefore, I can solve for S and S prime because y and y primed are known and f is known, so I have enough information to determine what they're asking. So we can start with equation 34.17, and we can eliminate one of these variables. In this case, I will eliminate S primed, and then once we have done that, we can substitute for S primed in terms of S to this equation, then solve for S, and then go back to whatever, however we define S prime in terms of S here, and then determine S prime that way. So from this equation, I have that S primed is equal to minus y primed over y times S. And y primed is 13 millimeters and y is 4 millimeters, and that's times S. So I get 3 point, so that's a minus 3.25 S. Okay, so I have S prime is minus 3.25 S. Now I could substitute for S prime in terms of S in equation 16, so I have 1 over S plus 1 over minus 3.25 S is equal to 1 over F, which is 9 centimeters, okay. And now I can easily solve for S, right? So I can just put this side over a common denominator and then just isolate S by itself. So I have then 3.25 minus 1 over 3.25s. And that's equal to 1/9 centimeters. And then I can solve this for s, and that gives me an s of 6.23 centimeters. And now I can go back to this relationship where I have s primed is equal to minus 3.25s. And I have s over here, so s primed then is minus 3.25 times 6.23 centimeters. So that gives me an s primed of minus 20.25 centimeters. Okay, so we have determined s and s primed as asked. Since s prime is negative, the image is a virtual image.